screen? Can you see this?
Yeah.
Yes.
Yeah.
Perfect. Okay. All right. So the first one, the table shows a discrete probability distribution. Find the probability that x is greater than or equal to 2. Very easy. These are the probabilities of each number occurring. For it to be greater than or equal to 2, we're just going to add up from 2 to 6. So 0.16, 0.08, blah, blah, blah. Or you could do 1 minus the probability of it being 1. So that would become what, 0.76. Any questions? Just please stop me if something sounds weird or confusing. The expected value of the probability distribution below is this. The expected value. Okay, the expected value. Does anyone remember what the expected value is?
Is it the mean?
It is the mean. Good work. So the mean. And the mean can be just done by the sum of x times the p of x. So the x, the score, multiplied by the probability of that score occurring. So 1 times 0.6 plus 2 times 0.1 plus 3 times 0.2 plus 4 times 0.1. The answer is D. All right, the value of t in the probability distribution, well, value of t, what must the probability always add up to? Just 1. So 1. Sum up all these and then obviously take away. That's easy. Which table represents a probability function? Well, it must add up to 1. That would be the rule. So let's have a look. That's 0.5. That doesn't add up to 1. This one, 60 and 40, that adds up to 1, I think. So I think it's D, but let's check the others. 70 and 40, that doesn't add up to 1. 30, 90, 1.1, that doesn't add up to 1, so the answer is D. This is easy stuff, right? Yeah. That looks easy. Evaluate K, same thing. You just add them up. 5K plus this, plus this, plus this, plus this must equal to 1, and then just solve. All right. There we go. We can try this one. For this, find the mean, variance, and standard deviation. The standard deviation is the square root of variance. So you have the probability function, P of x, which equals to x on 15, for x is 1, 2, 3, 4, 5. So that means when x is 1, I'll put it, you guys will be used to it like this. When x is 1, you get 1 on 15. X is 2, 2 on 15. 3, 3 on 15. 4, 4 on 15. 5, 5 on 15. And then you would hope that when you add up all this, it gives you 1. Or we can check it like this. 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 2 is 14. 14 plus 1 is 15. This would give you 15 over 15. But anyways, find its mean. So mean equals mu equals E of x. You got to get used to it. They're all the same thing. That equals to the sum of x times P of x. So 1 times 1 on 15 plus 2 times 2 on 15 plus 3 times 3 on 15 plus 4 times 4 on 15 plus 5 times 5 on 15, which, let me do real quick, plus 4 on 15 plus 9 on 15 plus 16 on 15 plus 25 on 15. Answer is 11 over 3. That's mu. Any questions? I didn't think so. Variance of x. Variance of x, there's a few formulas. Which one shall we do? We shall do expectation of x squared minus mu squared. But there's a few of them. All right, just so you know. And you can do either one, it shouldn't make a difference. Okay, so e of x squared, don't forget, if e of x was this, e of x squared means it's the sum of x squared, just like your functions, right? When I gave you something like this, let me just rewrite it. If I gave you f of x is x, I told you what's f of x squared, you just replace x with x squared. So same thing with this guy, e of x is there, you replace it for x squared. So you're summing x squared, p of x, that's probability, so that shouldn't change. And then minus 11 over 3 squared. So this guy looks like this. 1 squared times 1 on 15 plus 2 squared times 2 on 15. You get the idea, I hope. 3 squared times 3 on 15 plus 4 squared times 4 on 15 plus 5 squared times 5 on 15, take away 11 on 3 squared. And then we're going to answer for that. Give me a second. Let me work that out for now. Okay, well, that worked very nicely. 15, take away 3 squared, which becomes minus 11 over 3 squared. 14 over 9, and of course, what's the standard deviation? Square root of 14 on 3. Sorry, one of you, that's... Any questions? Okay, let's move on. Have a look at some more. These are easy, between 7 and 9. Yeah, broad screen, easy. A spinner has the number of values space and draw probability is assumed the following find probability. Easy, a function is given by this, find f of 3. Easy, construct a probability distribution, state whether. That should be easy. Represent a discrete probability function, find e of x, that's the probability of each one occurring. Do you guys remember that? So if it's written like this, 3, that means the score is 3, and the probability of the score occurring is 21%. That's 5, and the probability of it is 14. Does anyone actually need me to do this one, or you feel like that's pretty much the same as what we just did? Yeah, I thought so. Okay, what I might just do, I mean, there are some challenge questions, but I remember there being a exam question. So let me just quickly have a look for one. Nope. Nothing there. There it is. Let's find one. So let's open up that. There you go. The probability distribution of a random variable x is shown. What is the value of k? That's really easy. You're just going to add it up. So we're not even going to be bothered doing that. Let's just try to see if we can find one that's a bit... This is a prelim exam, by the way. So this covers the whole year. Okay, so let's try this one here. A bag contains 3 red cards and 2 white cards, because it's worth, I don't know, 7 marks. So let's see if we can try to answer this. A bag contains 3 red cards and 2 white cards that are identical in all respects except color. So 3 red and 2 white. 2 cards are drawn at random without replacement. Find the probability that the 2 cards are different colors. For them to be different in color, you would need to have your first one to be red. Oh, over there. You would want the first one to be red. What is happening? I hate Word. Come on. There we go. The first one's going to be red, followed by white, and then obviously you're going to add white with red. So red, white, and then white followed by red, which would be, is this without replacement? So the first one for it to be red is 3/5 times 2 over 4, because there's 1 less card, plus 2/5 times 3/4. Right. Any questions there? That's basic probability, which I have at the moment skipped, because I believe you guys should be able to do that when you learn it at school. But there's that one. Let me know if there's any questions there. Otherwise, we'll start B. That was worth 2 marks. If the cards are different colors, then 2 fair coins are tossed. If the cards are different colors, so if this happens, then 2 fair coins are tossed and the number of heads recorded. If the cards are the same color, then the 2 fair coins are each tossed twice and the number of heads recorded. Let X be the number of heads recorded. Okay, let's do that again. If the cards are different colors, then 2 fair coins are tossed and the number of heads recorded. So just 2 fair coins are tossed once. Okay, so 2 fair coins are tossed. Okay, yep, I get that. Number of heads recorded. Cool. If the cards are the same color, then the 2 fair coins are each tossed twice and the number of heads recorded. All right. So for this first case, let's let X be the number of heads recorded. Find the probability that X equals to 0. So no heads recorded. That means 0x. How am I going to think of this one? Give me 1 sec to think about this. If the cards are different colors, then 2 fair coins are tossed. Do I need to take that into account? Cards. Okay, 2 coins. So that would be tail, tail, head, tail, head, head, and obviously tail, head. If 3/5. If not, if it's 2/5, which means that they are the same color, 2 different colors. So 2/5 would be if they're the same color. Right, let's have a look. 3/5 times 2/4 plus 2/5 times 2/5 times 1/4. Let me just see. 6/20 plus 2/20. Yeah, it's 2/5, which is good. Just want to double check that. Then the 2 fair coins are each tossed twice in the number of heads recorded. So if each coin is tossed twice, that means technically there are 4. 2 fair coins are tossed. Then if 2 fair coins are each tossed twice, does that mean there's 4 cases? Is that how you guys are interpreting that? And 2 fair coins are each tossed twice. So that means the first one could have been tail, and then tail for the first coin. And the second coin could have also been tail and a tail. Yeah, so it could have been tail, 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 tail. Or it could have been tail, 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 heads, so on. Yeah, that's how I see it. We'll find out when our answer becomes wrong. All right, let's see. What am I thinking? I'm thinking, well, actually, in case I do get it wrong, and I'm about to say something and then you guys are going to learn it, let's make sure we're on the right track. Yeah, I was right. So this is 4 times. Be serious, come on. How does this thing work? All right. TT, so if the cards are the same color, then the 2 fair coins are each tossed twice. So that means each coin will have 2 outcomes. Sorry, it's tossed twice. So two outcomes, yeah. That's your first coin. So altogether there are 4 outcomes for this second case if they're the same color. Do you guys get that, or did I lose you while I was thinking?
Yeah.
I lost you there?
Yeah.
All right, well, let's just look at it again. Look at this. So if the cards are different colors, so if this occurs 3/5 of the time, then 2 fair coins are tossed. So 2 coins are tossed, right? This will be the first coin. This will be the second coin. This will be the first coin. This could be the second coin. This would be the first coin. This could be the second coin. This could be the first coin. This could be the second coin. Do you agree with that?
Yeah.
That bit there? All right. If the cards are the same color, which means that occurs 2/5 of the time. Do you understand how I got 2/5?
Yeah, I get that.
1 minus this, or I even did the math again if you really wanted to do the math here. But anyways, then the 2 fair coins are each tossed twice. So that means the first coin and the first coin. So the first coin I tossed it, I got a head. And then the first coin I tossed it again, I also got it, I got a head, I got a tail. The first coin I tossed it again, and I also got another tail. Let's hypothetically say. Then I tossed the second one, I got a tail, and I tossed the second one again, I also got a tail.
Yeah.
Does that make sense?
Yes.
And so on. And I mean, the outcomes just keep going. Tail, tail, tail. The second could have been head. Tail, tail. This could have been head. Then this could have been tail, and so on and so on and so on. You get the idea.
Yeah.
We're going to be here all day. All right. The thing is, every single one after this first one is going to have a head somewhere. Do you agree with that?
Yeah.
Knowing that, oh, this happened again. Okay. Knowing that means technically you don't need any of this when you're trying to work out the probability that the number of heads recorded should be 0. That means technically you want to find the probability of getting 4 tails.
Yeah, that makes sense.
Or you want to find the probability here of just getting 2 tails. So find the probability that number of heads recorded will be 0. Well, that will happen 3/5 of the time. 3/5 of the time at a half times a half, which is a quarter. In this case. Yeah?
Yeah.
Plus, and then obviously 2/5 times. What's the probability of this occurring? Well, isn't that just a half times a half times a half times a half?
Yeah.
Which is 1 out of 16. And that should be the answer. Yes, on the money. And there you go. I mean, here, at least you get a marking guideline that tells you what you're getting your marks for. 1 mark, the probability of the same color or no heads. So even if you got 2 out of 5, which is the first thing I did, you get 1 mark for that. 2 marks makes significant progress. So significant progress is really hard to work out what that means, but I would say significant progress is at least showing you understood 0 heads means tails, tails, just all tails, at least. And then, 3rd mark to get the correct answer. What was the answer again? 7 out of 40. Anybody have any questions for us there? The bit that annoyed me, and which is what I was trying to just take my time with, was just this bit here that said 2 fair coins are each tossed twice. So I just had to think, is that going to be 4 outcomes, or was that just another way of saying 2 outcomes? But it is 4, obviously, if it's each tossed twice. Okay, next one says find the probability that x equals 2, and you can see it's at the end of the paper. So they're pretty much trying to say that this is the hardest bit of the year 11. Advanced, but anyways, find the probability that x equals 2. So that means find the probability that the number of heads recorded, number of heads equals 2. Well, that occurs, there you go. So 2 heads would occur 3, so again, 3/5 times, how would you get 2 heads? Again, that's a half times a half, which is a quarter, plus 2/5 times, when would this occur? 2 heads. Well, if I just continue this pattern, tail, tail, head, tail, 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 head, head, and I mean, you can just keep going, tail, head, tail, 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 head, tail, head, and so on and so on. Okay. Now, there's going to be a few. So, how am I going to teach you guys how to do this? One, would you do it through combinations? But it's in 2 unit. So you would just have to count them, right? Yeah, fine. Okay, here we go. So, if I had to do this, what would I do? I would tell you to do head, head. Then I would say, change this. Okay, this is how I would do it without trying to list out all of them. I mean, of course, listing out is not a problem. But let's just say I drew 4 circles. I would say these 2 are not going to be heads. These 2 are heads. So if I did head, head, right, I would say, okay, that's 1. Now I'll keep a tally. So head, head. Then I go, okay, now that's going to be tail. Keep that as head. Then I'll make this into a head. And obviously that was a tail. So that would be 2 cases there. Then I would be thinking about moving that H into the first slot. So that would be three times. And then the idea is, because I've just moved, I've kept this fixed and I've moved this and I've worked out how many heads I get, I know that if I had to rearrange this, and if this was for T, never going to open up this again. No, God, okay, that's it, done. Don't worry about this. If this was a T here, if this was a T, and this would have been a T, and this would have been a H and a H, this would have been symmetrical, so I know I could just times that by 2. So that's technically 6 cases out of 16 cases altogether, which we knew from up here. Does that make sense? If the symmetry property there doesn't make sense, then you could just list it out, if that's easier for you. All right, maybe another exam question. Anyone still copying anything down?
Sam, if we were gonna do it with
If you were to do it
with combinations, how would you do it?
To get 6 out of 16, you are trying to select 2 heads from a possibility of. You're trying to select 2. So, what is a binomial? Is the problem with this technique? Let's see. You got 4 slots. You're choosing any 2. So you got 4 slots and you're choosing any 2, right? Yep, 4 slots, you're choosing any 2. Yeah, times, you've got a half to the power of 2 and a half to the power of 2. But we haven't even done binomial. I mean, have you done binomial expansions? Binomial probability?
No.
Yeah. You've done combinations, so I mean you could do the first bit. So you've got 4 spaces, 1, 2, 3, 4. And how many are you choosing? And
2.
why am I doing choose and not P? Because choosing order doesn't matter.
Selecting, not arranging. Yeah.
Yeah. And I don't even do P, just so you know. I do factorials like we said. But so 4 choose 2, and then what you're meant to do after you've chosen your 2, you go, okay, what's the probability of each case? Well, you've only got 2 different probabilities. You've got the probability of it being half. Now that's disabled. That's great. It's not even letting me write anymore. Oh, there you go. Okay. Half. Get lost. Half to the power of. Now, how many heads do I want? Pretty much. 2. Now, and then what's the other case? The other case is tails, right? So that's also half. And how many tails must you get?
2. You want 2 tails.
If you do that, I promise you'll get 6 out of 16. Test it just quickly and confirm you do get 6 out of 16. So there's so many ways. I mean, look, again,
you do.
You're making a good point. Like, see, some students start to go, okay, you've taught us this because we were doing permutations and combinations, and that's the only way we've meant to do it, or binomial, and that's the only way. No, you can just do your basic probability stuff. Like, I mean, who cares? Just go do 6 out of 16, and that's it. So don't get caught up with the topics. Once you learn, pretty much by the stage, I would say by the end of this term, when you guys have finished off all of year 11 and pretty much all of integration for like extension 2 and all that, you should have fun, like mathematical freedom. You can be free with anything. You can do any particular concept at any stage of any topic. You don't have to be so strict with your math. So that's a typical case. Like, you could do basic probability, you could do combinations, you can do binomial probability, which is specifically this. I mean, you can do a lot of stuff, but at the end of the day, as long as, all of math works together. So whatever you're doing, as long as it makes sense, it'll work out.
Okay. All right. Thanks.
All good. This time, I'm going to open you up. I'm going to convert it. I'm not going to write on this thing. It lags. All right, let's make sure there's another. I'm assuming they're at the end, so I'm just going, ooh, that's a good one. A lot of students didn't know that one. Let's open it up. Yeah, look, end of paper again. See, I realized that now. All right, we'll do one more. Find, save as, convert that to PDF, save. Now I can actually open it up in here and write freely. And the solutions would be this. So let's open that up to double check it all. Okay. Let's do it. Let's see if we find one in multiple choice. Yeah, but I'm not going to do basic probability. There it is. What does this one say? There it goes. What is the value of EX? Again, we know it. Just 1 times this, plus 2 times this, plus 3 times this, 4, 5 times, 6 times, and then you should get an answer. This is worth 3 marks. A spinner is showing the numbers 1, 2, 3, 4, and it's spun twice. Let X be the sum of the 2 numbers obtained. So you can get 1 plus 1, which is 2, 1 plus 2, which is 3, 1 plus 3, which is 4, 1 plus 4, which is 5, 2 plus 3, which is also 5, 2 plus 4, which is 6, 3 plus 4, which is 7, and then 4 plus 4, which is 8. Complete the following table of discrete probability distributions. So, like I said, yeah, all right, I'm just going to show it to you. So you get, this is the way I would do it. I would list out 1, 2, 3, 4. And I would also list out 1, 2, 3, 4 this way, because it's spun twice, just like you would have done with the dice, let's say. And then you're meant to X be the sum of the 2 numbers, so you could get a 2, 3, 4, 5. You get a 3, 4, 5, 6, and so on. 4, 5, 6, 7. And then, like I said, 5, 6, 7, 8. You can get an 8, 1 out of 16. You get a 6, 3 out of 8, 3 out of 16. You get a 4, 3 out of 16. And you get a 2, 1 out of 16. You get a 3, 2 out of 16, which is 1 out of 8. You get a 5, 1, 2, 3, 4 over 16, which is a quarter. You get a 7, 2 out of 16, which is an 8. That makes sense, doesn't it? You guys might not be used to it just yet, like listing it out and maybe finding these probabilities the way I just did it, but I think you'll get the hang of it as you do more basic textbook questions. That's an easy 2 marks. And then what is the probability of getting X between 4 and 8? But it does not say including 4, right? So that means it has to be 5, 6, 7, and 8. So a quarter plus 3/16 plus an 8th plus 1 on 16, not including 4. So what is the probability? Not yet. Probability that your 2 numbers obtained, the sum of your 2 numbers obtained, is less than or equal to 8, but somehow bigger than 4. So it has to be 5, 6, 7, 8. And you get an answer. Any questions? No? All good? All right. Let's move on. All those basic differentiation questions. Look at that. All right. The probability distribution of a random variable m is shown below. Find expect E of m. I'll let you guys just quickly do that. Give me an answer for that one. You're just multiplying, adding. So go ahead and do that. Doing that real quick on my calculator as well. $4.875. Anybody not get that? No, all good. Okay. X E of 2m plus 5. I didn't actually see any of these in the textbooks, but it's good. It's funny that it comes up in exam questions. Isn't that a typical typical thing? I wasn't in the textbook questions, and somehow I was in the exam. So there you go, right there. E of 2m plus 5. Okay, how does this work? These have rather interesting properties. So E's, you can expand. So the expectation of 2m plus 5 is actually E of 2m plus e of 5, ooh, hold on. Again, I'll rather check this just because this isn't my kind of math. But let's make sure. Oh, Sam, you still got it. Oh, plus 5. Of course, actually not 0. Okay, fair enough. Expected value of 5 is 5. That is silly by me. Why was I thinking 0? Variance. Variance of 5 would be 0. Okay. So like I said, you can break this up into e to m plus e5. E to m is the same as 2 times e of m. So 2 times the expected value of m plus, now the expected value of 5 is 5. Just like so the way that works, that's just a simple rule. The expected value of x is x. If x is a constant, because isn't e of x meant to be average or mean? So if I say, what is the mean? What is the mean of 5? The mean of 5 is 5. All right? So e of x would equal to x if x is a constant. I was thinking of variance when I wrote 0. Variance of 5 would be 0. So variance of a constant is 0 because it hasn't varied any way from its own mean. Well, there you go. And then you get an answer, whatever that becomes. Any questions there? No. I think it's just a good point to make with the amount of textbook questions I guess we've done compared to exam questions. You can see I did a lesson on the textbook questions, but jumped straight onto exam questions. That's it. And you can see we've been able to answer most of it. So you don't need to waste so much time trying to work on your textbook style questions. It's better to just jump and look at exam questions. Oh, that's an easy one. Show that cot theta plus tan theta. Too easy. Given, we're going to do logs. Solve, we're going to do that. Rates of change, we're going to do that. Find the exact area of the region, the equation. It's big, right? Your prelim exams, it's going to have a lot of work. You got to know. All right. Let's see. Probability distribution. What is the value of t? That's easy. 12t plus 2t plus 3t plus t plus 2t, 2, 3, 6, 8, 20. Find the expected value of the probability. Oh, are you serious? Find e of x. Okay, that's easy, isn't it, you guys? Do we need to do that or can we move on? -3 times 12. This, right? Expected value, you're just going to find the mean. Right? Does anyone want me to actually do that? No? You sure? All good? Done. All right. Out of the way. Finished. Go on. I'll stop that recording actually for now.